Good morning, good evening, good afternoon, depending on where you are getting us from. Welcome to a sub-part of Lecture 3 on Solar Power Engineering. In this lecture, we discuss and talk about solar PV systems, building on the knowledge that we have so far looked at. In the part of solar PV power systems, we look at tradition versus modern systems. Tradition and modern systems. These are basically practical systems that are there. So in the previous lecture of part 3, we looked at the solar PV power systems potential. So here I show you the global potential of the kilowatt hour per kilowatt peak. We can see the various potentials for Africa, North America, South America, Australia, Asia, India, and of course, Zambia and other countries. So this one gives us a potential or expected generation capacity in terms of the kilowatt hour per kilowatt peak that is expected. So when we look at solar PV systems, it's basically important and essential to look at the classification of the technologies or the PV systems. How do we classify them? What is there? How do we make a decision that what we are going to actually apply for a particular solution is good and is going to serve the purpose? So in doing so, we have to recognize the benefits and the limitations of the system or technology that we are going to do compared to other systems that are there. So once that is done, there is also need to make an identification. Okay, are we going to go with standalone systems or we are going to go with hybrid systems? So once we have an identification of the common application that we must do, we are now supposed to characterize the components and their roles in this system. Okay, so as we continue to build on the knowledge, it's also important to understand the choice of inverters and charge controllers for your PV system, because these will be crucial for the successful operation of your system. So when we go a bit backwards, we showed the traditional solar PV system previously, and also in comparison with one of the modern power systems. But again, when we look at these, we have got all the actual components being there. This also gives us a requirement on the protection aspect of our system, because our solar PV system is actually and essentially a complete power system which should have got power reticulation and protection of the components and also the loads that are going to be connected. So this is an example of the traditional power system. Of course, when we expand, this is in a simple illustration, we go to a more advanced traditional system. So in this more advanced traditional system, we have got a lot of batteries, we've got a lot of solar panels, and also we have got also an arrangement of 2 charge controllers. So now, what we are actually trying to say is, when you have a lot of solar panels, you have got to have the combiner boxes. So when you look at the part 2 of our traditional system, we have got the combiner boxes. These combiner boxes will actually arrange properly our strings of solar PV that we have, so that we have got just one single output going to our charge controller. And then when we look at this configuration, it's an advancement from this configuration where we've got one panel, one charge controller, one battery, and an inverter. This is a typical of a 12-volt system. Now, when we go further, if you look at the configuration, this is giving you 2 or 4 batteries in series. And then you have got parallel arrangement of 4 lines of this battery. So this essentially gives us a 48-volt system, okay? And once we have a 48-volt system, it means 1 unit of battery should have actually 4 12-volt batteries. So this is essentially important. When you are going to do bigger systems, going higher, 10, 20, 100 kilowatt, 1 megawatt, the combiner boxes actually becomes very much essential. If it's a very small system, we don't actually need the combiner box. So this gives us an advancement and improvements on what needs to be done. Of course, in this traditional system, the protection aspect has not been shown, but we still maintain that for a system, you still need the protection to be there. So now, on my right is a modern system, a simple modern system. So if we go further on our slides, we find now this is a modern system that is there. When we go backwards, we see the application of the gel stroke AGM batteries, which is one type of storage. In the previous video, as a complementary part of the energy storage, I've actually shown a lithium-ion assembly example. So here we see that we have got a low power solar battery, which is lithium. And then we have got an hybrid solar power system inverter, which has got an inbuilt charge controller. So what we are actually saying is that we move our charge controller inside the inverter. So now it becomes easier to actually do your implementation. So in such a way, you are able to actually supply your household appliances. One thing that can actually be realized is when we have got gel batteries, some of the most active loads cannot actually be supplied. But when we have got lithium ion has got the battery management system inbuilt in them. So the protection when it comes to charging, overcharging, cell over voltage is actually enhanced. When we have got gel, we only depend on the protection, inbuilt protection for the charge controllers. But then when we go to lithium, we have got 2 levels. The inverter will control the charging of your lithium-ion battery. And of course, even the lithium-ion battery itself will control the charging aspect. So now this is in line with the power reticulation aspect. Now, when we add a second level of control, where we have got communication between the lithium and the hybrid inverter, then you actually have got optimized operation. So this is one aspect. For example, we can take, this can be a 10 kilowatt hour, 15 kilowatt hour, or 5 kilowatt hour. But then when we want to build a very big storage system, then we can actually move a step further and have either stackable battery. So we can see that we have got battery 1, battery 2, battery 3, battery 4. If we take an example of saying one battery is 10 kilowatt hour, so essentially what we have is 40 kilowatt hour of storage aspect. So in building your system, you can actually decide, make a decision. When we go backwards, you have to actually do the characterization of your components and their role. You have got to identify what is this application. For complete off-grid, where you don't have a diesel generator, you only need power from solar. It becomes easier to make a decision to go with one which has got no inbuilt. But if you are going to have a standby utility or even a diesel generator, so you can actually go for the one which is hybrid and also with inbuilt charge controller. So this is some of the things that we continue to discuss and look at. So you have got the traditional power system, which is this one and this one. Then you also have the modern power system. So now what we are saying is, in each application, either modern or traditional, you can actually use lithium or gel. The decision lies in determining the lifespan of your batteries. Of course, lithium ion with the added control aspect can actually go on to live longer, even at 100% of depth of discharge. But also one thing I can also mention is with gel or AGM, if you go with 40 to 50% of DOD, which is the depth of discharge, you can also attain a life that is a bit longer and sustained. But that will add a bit of expense to what you have. So in this lecture, we actually just wanted to look at the two, tradition and modern system, so that you have got a picture you can visualize. When we start to design, we start to look at production aspect, looking at the potential, how much we can produce in an hour, in a day, in a week, in a month, and even in a year, so that you can optimize your system to work efficient and effective. Thank you very much for following this lecture. You can subscribe, like, and share. You can also send your questions and comments to enochlurio1@gmail.com. We can actually set up an interactive Zoom meeting so that I can answer some of the questions that you may have, depending on where you are. Thank you very much. Thank you, India. Thank you, Africa. Thank you, North America. Thank you, South America. Thank you, Asia. Thank you, Australia. Thank you, Oceania countries, for following up and learning. Until the next time, it's bye for now. Thank you very much, and see you in the next lecture.